First of all, we are in a very exciting time. We all hear about AI, we all hear about the transformation of everything we do, around AI. These things are happening right around us. What's the foundation? How are they all coming about? Semiconductors is foundational to everything digital. Today, there is not one thing that we do in our lives that doesn't, in one shape or form, has digital aspect into it. In order to enable this industry, right, you have to make sure that you're providing the skills.
This is a pretty highly specialized field, so somebody that comes out with a degree in one of our traditional engineering disciplines, for instance, has the fundamentals, they have the background they need to be successful in a career. And I think what our Semiconductors initiative is really trying to do is help them get a jump start so that now they're kind of well versed in some of the key technologies, the key issues in the industry. We actually have programs that start in the first year of college for our first year students, things like our Changing the World with Chips course that brings in industry speakers to get students interested and engaged in the field. We have over 100 semiconductor focused courses across campus. We have a number of experiential learning programs where students can apply what they've learned in lecture courses to practical problems and build more in-depth expertise and experience. We have a campus-wide semiconductor certificate, departmental concentrations in 4 departments, and master's programs, both residential and online.
Within the certificate, the first class you take is a Changing the World with Chips course. I was able to learn more about what semiconductors really is and what it holds for within industry, and then I found it interesting, and trying to get that foot into the industry, it is a bit of a learning curve. So that's why, for me, that certificate is allowing me to be able to learn more and be better prepared for the industry. I've taken various courses up to this point, and one of the classes I've enjoyed so far is EC 506, 3.1, and 3.2 and 3.3. It's a combination of 3 1-credit-hour courses, and I find that very interesting, and it helps me to better understand more about the physics sides of things. I see it as a great opportunity for students to be able to have exposure to those topics and to those that kind of information that usually they wouldn't have access to, and in that way they can better prepare for the industry, as it did for me.
The Semiconductor Degree Program allows students with different educational backgrounds to develop expertise in semiconductors. This can be chemical engineers, industrial engineers, physicists, computer science. And from industry's perspective, this is the most valuable kind of semiconductor degree to have a broad technical or educational background.
PERC has just celebrated their 20th anniversary, so in some extent it's an established center, but also over the last few years they've undergone a significant upgrade and renovation. And this has been a unique Purdue thing. There's a lot of universities that have clean rooms. Many of them are trying to make those accessible to undergrads in some way. But I think Purdue has really leaned into this very strongly. I think it's given our students an opportunity to really have experiences that very few students get at most other universities.
The semiconductor industry has rapidly innovated, and it doesn't happen without people being ready to go and ready to tackle those challenges. You don't get to following Moore's law and doubling transistor power every 2 years without significant technical hurdles that people have overcome over decades. And we've been able to keep this up because of innovative people taking on the challenge and willing to step up. Purdue students shown that they're capable of taking on this workload.